Hey, welcome to our notes for describing polynomials. And before we get started with the examples, we're going to look at the vocabulary for this lesson. We'll start with standard form. So a polynomial is written in standard form when its terms are listed in order by descending exponent. So for example, if I had a 2x to the fifth power minus 3x squared plus 7x minus 2, for example, right, this would be considered standard form because my highest exponent term is listed first, and then my next lowest exponent term is next, right, because 5 is greater than 2, right? This is a 7x, that's my linear term, that's to the first power. And then the constant here at the end, the 2, recall, is x to the 0 power, because anything to the 0 is 1. And 1 times negative 2 would be 2. So a constant always has x to the 0 power. So notice how our exponents are all listed in descending order. Right? Sometimes your polynomials are not given to you in standard form, and you need to rearrange them to write them in standard form. So for example, if I had a polynomial in factored form, 2x times x plus 3, for example, right? This would be factored form. I would need to distribute in order to get rid of those parentheses. So that would simplify to 2x squared plus, and then 2x times 3 is 6x. So now this polynomial would be in standard form, right? It's in order by decreasing exponent. Okay, the degree of a polynomial is the highest whole number exponent in the polynomial written in standard form. Or in factored form, it's the sum of the exponents in each factor. So in our first polynomial 2x to the fifth minus 3x squared plus 7x minus 2. In that polynomial, my highest exponent is 5, so this would be a degree 5 polynomial. In my second example here, this 2x times the quantity x plus 3, that was factored form. The 2x factor is exponent of 1, degree 1. My x plus 3 factor is also a linear factor, degree 1, and 1 plus 1 is 2. So this would be a degree 2 polynomial in factored form. If I look at its standard form after I distribute, and there I can see my degree is my highest exponent term, which is 2. So you can either add the exponents from each factor, or if it's in standard form, look at your highest factored exponent, or your highest terms exponent in order to see your degree. Okay, then when you want to describe polynomials by their type, then you classify them by degree and by number of terms. So by degree, if your polynomial is degree 0, it's a constant. If the polynomial is degree 1, it's linear. If it's degree 2, it's quadratic. Degree 3 we call cubic. And then anything 4 or higher we describe as an nth degree polynomial. So for example, this 2x to the fifth minus 3x squared plus 7x minus 2, that polynomial would be a 5th degree polynomial because its highest exponent is 5. Okay, but in our second example, 2x squared plus 6x, this is a degree 2 polynomial, so we would classify that by its degree as quadratic because we call degree 2 polynomials quadratic. Okay. When you're classifying by number of terms, a one-term polynomial would be a monomial. A two-term polynomial is a binomial. So this right here would be an example of a binomial, 2x squared plus 6x, because it has 2 terms. Okay, a trinomial has 3 terms, and then an n-term polynomial has 4 or more. So for example, the 2x to the fifth minus 3x squared plus 7x minus 2 example would be a 4-term polynomial. Okay? And then the leading coefficient is what we call the coefficient on the highest exponent term. And in our first example, right, our highest exponent term is 2x to the fifth, so the leading coefficient of that polynomial is 2. So let's take a look at example 1, where we're going to put this information all together. So before we look at the degree, the leading coefficient, the type, we're going to need to put this polynomial into standard form. So I'm going to distribute this -3 to get rid of the parentheses, and I'll have x squared minus 3x minus 3 plus 2x squared. And then to get into standard form, I need to combine like terms. So 2x squared plus x squared would be 2x to the 4th power. And then my linear term will come next, so minus 3x, and then my constant is a minus 3. Okay, so the degree, remember, is the highest exponent on the highest exponent term. So 2x to the 4th means this is a degree 4 polynomial. The leading coefficient would be 2. And then the type, when I classify by degree and by number of terms, I have, because the degree is 4, we call that a 4th degree polynomial. And then by number of terms, we have 3 terms, so that would be a 4th degree trinomial. Okay, so let's go ahead and try the next one. So y equals negative x squared. I'm going to distribute this negative to get rid of these parentheses. So my negative x squared minus 1, then minus 2x, and then a negative times a negative is a positive x squared. And then I want to combine my like terms to put it into standard form. Negative x squared plus x squared is 0. Then my linear term would be first, so negative 2x, and then my constant, which is a minus 1. Okay, so when I'm classifying by degree here, and this is a degree 1 polynomial, I would call that linear. And when I'm classifying by number of terms, I have 2 terms, so this is a linear binomial. And its leading coefficient is negative. Okay, so in our next example, we've got a negative 2x, and that quantity is being cubed. So that's a negative 2x times another negative 2x times another negative 2x, right? That's what negative 2x quantity cubed means. Negative 2 times a negative 2 times a negative 2, that's a negative 8x to the 3rd power. Okay, then minus 8 plus 8x to the 3rd power. So negative 8x cubed, then minus 8 minus plus 8x cubed. Okay, that negative 8x cubed in the front here plus 8x cubed in the back, those cancel and leave us with just the constant of negative 8. Okay, a constant is a degree 0. Right, because recall that that's the same as negative 8x to the 0 power, right? Because anything to the 0 power is 1. So degree 0 polynomial, and the leading coefficient is negative 8, and that is a constant monomial. Okay. So if you want to pause the video then and go ahead and try the last 2 problems here on your own, and then when you're ready to check them, you can resume. Okay, so hopefully you took a second to try these last 2 problems in example 1 on your own, and then we'll go over them together. So we want to take this factored form of the polynomial and put it into standard form. Before we do that, though, remember from our notes on the front that you can find the degree in factored form by adding the exponent in each factor. So this factor of x squared has an exponent of 2, and then I have an x plus 1 quantity squared, so that would be the same as an x squared factor, right? That's times a factor of x plus 1 times another factor of x plus 1. That's what x plus 1 quantity squared means. So when I add my excuse me, my exponents in each factor, 2 plus 1 is 4. So this would be a degree 4 polynomial. And I can tell that without even having expanded it into standard form yet. I can also tell what my leading coefficient is going to be because that highest exponent term will come from multiplying these three first terms together. So x squared times x is x cubed times x is x to the fourth. And that means my leading coefficient will just be the coefficient on that x to the fourth, which is 1. Okay. Now when I go to put that into standard form, I'm going to have to FOIL these two binomials together. So x times x is x squared. And then I have x times 1 on the outside is 1x. X times 1 on the inside, that's another 1x. And x plus x is 2x, so x squared plus 2x. And then that was first, outer, inner. Now I'm going to do the last. X times x is, 1 times 1 is 1. So I have a trinomial now of x squared plus 2x plus 1. So that was FOIL, if you remember from Algebra 2. And then I still have this factor in the front of x squared that I bring down. And then to get rid of the parentheses, I'm going to distribute. So x squared times x squared is x to the fourth power. Then x times 2x would be a plus 2x to the third power, so x squared times 2x is 2x cubed, and then x squared times 1 is a plus x squared. And now that we're in standard form, you can see that we were right with our degree being 4, right, and with our leading coefficient being 1. So when we classify this by degree, since the degree is 4, we would call this a fourth degree polynomial, and then it has 1, 2, 3 terms, and so we call that a trinomial. So this is a fourth degree trinomial. Okay, then our last example here, we have a 3x quantity squared, so that's 3x times 3x, which would be 9x squared. Then minus 5x cubed plus 1 minus x. And when we want to put that into standard form, it has to be in decreasing order of exponent. So our negative 5x cubed term would be listed first. So negative 5x to the third power. Then our quadratic term would come next, and that's plus 9x squared. Okay, then our linear linear term is a negative x, that comes third, and then in fourth place would be our constant, plus 1. So we have a degree of 3, and we call degree 3 polynomials cubic. So this is a cubic, and it has a leading coefficient of negative 5. And 1, 2, 3, 4 terms. So this is a cubic 4-term polynomial.